Hello everyone, welcome back to my channel. Today we are going to start an amazing and very important chapter in physics, light, reflection and refraction. In this video, we will cover everything from the basic properties of light to the concept of reflection, image formation by the spherical mirrors, including step-by-step ray diagrams. So make sure to watch until the end. Take notes and let's get started. First, let us understand what light actually is and look at its core properties. Light is a form of energy that enables us to see the world around us. It is an electromagnetic wave, which means it does not require any material medium to travel. Light always tends to travel in a straight line path. It also has a dual nature. It means it exhibits the property of both waves and particles. Light casts sharp shadows when an open object comes in its path. In a vacuum, the speed of light is at maximum, which is 3 into 10 power 8 meter per second. Finally, when the light falls on any surface, it can undergo three phenomena. One is reflection, refraction, and absorption. Now, let's focus on a major topic, reflection of light. Reflection is simply bouncing back of light rays when they strike a highly polished surface like mirror. I will give you some examples. Let us consider we have a ball in our hand. There is a surface which is like a tiles or a polished surface. I'm just going to put the ball on the surface. What will happen? There will be a bouncing back of the ball. As well as when a ray of light strike the surface, it will be bounced back. So bouncing back of light is known as reflection of light. There are two fundamental laws of reflection that you must remember. They are the first law. The angle of incidence is always equal to the angle of reflection. Angle I is equal to angle R. Here, the angle I represents the angle of incidence as well as the angle R represents the angle of reflection. Next, second, the incident light, reflected light, and the normal all lights on the same plane. Okay. Again, the incident ray as well as incident ray or incident light, normal and then reflected ray or reflected light lies on the same plane. Next, when we go for the next topic is image formed by a plane mirror. Let us see how an image is formed by a flat plane mirror. As you can see in this diagram, when an object is placed in front of the mirror, the light rays reflect off the surface. If we measure the distance, the object distance, which represented as u, is exactly equal to the image distance represented as v. Here, u represents the object distance, then v represents the image distance. This means the image appears to be at exact same distance behind the mirror as the object is in front of the mirror. Let us consider you are going to a trial room. You are standing in front of the trial room mirror. Okay. Now, the distance between the mirror and you is around 10 centimeter. So you can able to see the same reflection of your image, same reflection of yourself in the mirror, which is called as image. So the distance between the mirror and the image is around 10 centimeter. So we can directly say that the image distance is equal to the object distance in plane mirror. Now, the characteristics of a plane mirror. What are the characteristics of this image found by a plane mirror? First, the image is always virtual and erect, meaning it cannot be caught on a screen. It stands upright. Second, the size of the image is equal to the size of the object. Third, as we just discussed, image distance equal to the object distance. Fourth, the image is laterally inverted. This means your right side appears as the left side. In the mirror, your left side appears as the right side. For example, I'm going to stand in front of the mirror. I'm going to comb my arm. By combing my hair, I can able to see that my left hand is equal to the right hand in the mirror. So it is lateral inverted. Now the next topic is spherical mirrors. What do you know about spherical mirrors? When we go for mirrors, there are two types of mirrors. One is plain mirror, the next one is spherical mirrors. Now, when we are talking about spherical mirror, there are two types. One is concave mirror, the next one is convex mirror. Now, let's jump into the world of spherical mirrors. Mirrors whose reflecting surfaces are curved are called as spherical mirror. You can imagine a spherical mirror as a small pot cut out from a large hollow glass sphere. Based on which the side is curved, reflecting, we can divide them into two halves. Are two types. They are concave mirror and convex mirror. The next one is concave mirror. Let's look at the concave mirror first. A concave mirror is a spherical mirror whose reflecting surface towards the center of the sphere. Or else we can directly say that the mirror whose reflecting surface is curved inwards is known as concave mirror. The outer and bulging surface is silver, polished and making it non-reflecting. The next one is convex mirror. When we go for convex mirror, in a convex mirror, the reflecting surface is curved outwards, facing away from the center of the sphere. Here the inner curved surface is silver, polished and non-reflecting. To be simple, concave mirror is curved outwards. When we go for convex mirror, it is curved outwards. I think you can able to understand, right? The next one. Before going into the ray diagrams, we need to understand some basic geometrical terms used in the spherical mirrors. Now, the first one is pole. The center of the reflecting surface of the spherical mirror is called as pole. Now, the next one is center of curvature. What do you mean by center of curvature? The reflecting surface forms a part of a sphere. The center of that sphere is called the center of curvature. Note that C is not a part of the mirror. It lies outside the reflecting surface. The next one is radius of curvature. The radius of a sphere of which the mirror forms a part is called as radius of curvature. It is the distance between P and C. To be simple, here P represents the pole, R represents the radius of curvature, F represents the focus, as well as 2F or C represents the center of curvature. Next one is principal axis. A straight line passing through the pole or the center of curvature is called as principal axis. The next one is principal focus. when a parallel ray of light falls on the mirror after reflection, they either actually meet at a point in a concave mirror or appear to be diverged. It is a convex mirror on the principal axis. This point is called as focus. Next point is called as focal length. The distance between the pole and principal focus is called as focal length. Okay. When we go for focal length, there is a relationship between radius of curvature and focal length, which means the radius of curvature is twice the focal length. So capital R is equal to 2f. Now, the important point is ray diagrams. There are three rules or three ray diagrams you should understand. Okay. To draw a ray diagram perfectly, we must look or we must follow four simple rules. Let's look at rule number 1. Any ray of light that travels parallel to the principal axis will, after the reflection passes through the principal focus. Let us consider this is a concave mirror. This line represents the principal axis. When a ray of light parallel to the principal axis, it comes back or it bounces back to the focus. This is the first rule. Okay. The same is happening in the convex mirror. Okay. Rule number 2, which is exact opposite to the rule number 1. A ray of light passing through the principal focus of a concave mirror are directed towards the focus of a convex mirror will emerge parallel to the principal axis after reflection. Let us make it simple. Let us consider this is a concave mirror. This is the principal axis and this point is called as center of curvature, focus and then path. Okay. Now, when a ray of light passes through the focus, it will come back as a parallel line to the principal axis. This is the rule number 2. Okay. Now, rules for the image formation are 3. Let's see rule number 3. A ray of light passing through the center of curvature of a concave mirror are directed into the direction of C are reflected back along the same path. To be simple, let us consider a concave mirror. This is the principal axis and a ray of light falls on the center of curvature of a mirror. It again comes back to the same path. This is the third rule. Okay. Next, we are going to see the fourth rule. A ray of light incident obliquely to the principal axis towards the pole of the mirror is reflected obliquely. The incident and reflected rays follows the laws of reflection. In the law of reflection, there is a smooth polished surface. When a ray of light falls on the surface, is called as incident ray, and then it gets reflected, which is called as reflected ray. This point is called as the normal. Like that, here, instead of a normal plane, we are going to use a curved surface. That's all. Okay. Now, we are going to study about the important points which are called as case studies. Now, let's combine these rules and draw the ray diagrams for a concave mirror based on different object positions. Case 1. When the object is placed at infinity, when the object is very far away, the incoming rays are parallel to each other. After the reflection, according to the rule number 1, all the rays meet exactly at the focus. So we can directly say that the image is formed at the focus F. Its nature is real and inverted, and its size is highly diminished or point sized. I think everyone can able to understand, right? Again, I will repeat. Uh, this is the case study one. When the object is very far away, we are going to consider a concave mirror. When the object is placed at infinity or when the object is very far away, the incoming rays are parallel to each other. After the reflection, according to rule number one, all the rays meet exactly at the focus F. So the image is formed at the focus F. Its nature is real and inverted. So the nature of the image formed is real and inverted. So what is the size? The size is highly diminished or point size, very tiny. Okay. Now we are going to the case study 2. What they are going to do about the case study 2? Let's bring the object a bit closer. When the object is placed beyond the center of curvature C, here we take one ray parallel to the principal axis which passes through the F and another ray passing through the center of curvature C. We already know the rule number 3. So we are going to combine rule number 1 and rule number 3 together to get the image formation. Okay. So they intersect between C and F. Therefore, the image formed is between F and C. Here F is the focus and C is the center of curvature. It's so the nature of the image formed is real and inverted. Size of the image will be diminished, smaller than the object with what we are going to place in front of the mirror. Okay. Now we are going to see the case study number 3. What's the case study 3? Let's move the object even closer. When the object is placed exactly at the center of curvature C, we take a parallel ray passing through F and a second ray passing through F. Now it becomes parallel. Both reflected rays intersect exactly below C. So the image is formed at the C. So now we are going to use the third rule. Okay. So the nature of the image formed is real and inverted. So size of the image will be same size. There will be no difference. This is a very popular questions in your board exams. Okay. Now the case study number 4. Then the object is placed between the center of curvature C and the focus F. As the object comes closer, the image moves further away. The rays intersect beyond C, so the image is formed beyond C. Its nature is real and inverted. So the nature of the image formed will be real and inverted. So the size will be magnified when compared to the normal object which we are going to place in front of the mirror. Okay. Alright guys, we have successfully covered the first 4 crucial ray diagrams for a concave mirror today. In our next class, we will look at what happens when the object moves even closer at F and between F and P. We will also explore convex mirrors. If you found this explanation simple and easy to understand, please hit the like button and share this button with your classmates. Don't forget to subscribe to the channel for more physics videos. Thank you for watching. See you in the next session. Bye bye.